Hi guys. Right, first look at the Tonfunk console radio chassis. Um, as usual with German engineering, no problem to get it out of the cab. It was just two screws and two sliding rails, and out it came. First thing I really like about this is the way there's actually mirroring on parts of the dial glass. I've not seen that on a dial before. I think it looks cool. Okay, a bit of cleaning up to do, but it looks generally in very good condition. For instance, if you look at the drive cord mechanism there, it's so clean, it looks like new. I had hoped I might find some sort of a model number on the chassis that might help me get a more accurate circuit diagram. I haven't really got a circuit diagram for it yet. I've got ones that I think are close, but all that has is a build number on the back. So yeah, we'll see. Lots of corrosion on the line input fuse here, so let's clean all that up. That's a dual 50 microfarad 385 volt electrolytic right there, so we'll have to check that guy out. The seals on the tops of the IF cans, this one was fully open, this one was partly open. These two actually feel closed, but the very moment I touched them, the center part fell away, so I don't know whether anybody's been in there or not. But as you can see, the whole thing looks extremely clean. And so yes, I'm optimistic. The one major challenge on this that I found is the same as I had on the Siemens, which is the AM tuning condenser. The grease on the drive shaft has turned to glue, and so it's completely solid. You just can't budge it. Now, the complication that gives me is on the Siemens set. When I did it, you have to take the whole thing apart, including the front metal plate here, so you can get at this pulley, because you got to take it off. I can do that. I guess I can do that. However, the complication is to do with this dial is in just such good condition, but you can see here that the rubber is perished. It's the same on the other side. That's holding this, just sort of wrapped around these various little pieces to hold it on. But the worrying thing is it is supported from behind by these rubber mounts, and I am totally petrified that that rubber mount is stuck to the glass, and if I attempt to lift off this glass, it's going to take a chunk of the paint off the dial, and I'll be left with an ugly hole right here in the front. And as you can see, there's multiple of these things at various points. So I am going to do everything in my power to not have to take this dial glass off, because the risks just seem to be way too high. However, when these guys go, they go pretty solid. So yeah, I will chuck every chemical I have at it to try and free that thing up before I give in and have to take the risk of taking this front off. The rest, hopefully, should be pretty straightforward, just a good clean up. I love the full 270-degree movement of the AM antenna, smooth as glass. Much better system than on the Siemens one I did. So at this point I'd say I'm going to stick some, I don't know, penetrating oil of some sort onto this tuning condenser. Give it a good clean up. leave it for 24 hours, and then see, because the strategy for where I go from here with this thing entirely depends on can I free out that tuning condenser or not. So, yeah, that's it for now. As I say, I'll keep hunting for a circuit diagram. I was kind of hoping, and I'm sure it does exist, I just maybe haven't found it yet, but the trade name that Tonfunk used for all their tabletop sets was Violetta. And so there are loads and loads of Violetta models on places like the RM Morg site. Just haven't found one that matches exactly the tube lineup I have in here yet. So we keep searching. Well, with some relief, looks like I managed to free out the tuning condenser. So one of my major concerns seems to be out of the way at this point. It turned out that the magic chemical which did the trick was that flux clean stuff that I used for cleaning off heavy duty fluxes, and yeah, the WD-40 didn't help, IPA didn't help, but a little bit of brushing with the flux clean onto the main miniature gear in there, and where is it? See if I can see it. This little guy right here, and it looks like we're good. So yeah, real pleased that's out of the way. So next, I guess, would be the power supply, electrolytics and stuff, and where the selenium rectifier is located, just underneath here, there's 2 layers of capacitors on top of it. So maybe tempted to do first power up while it's still in there. I normally would get rid of a selenium rectifier just as a matter of course. But I think this time out, since this thing was stored in such good conditions, I think I'll test the I'll test this electrolytic for leakage and whatever, and then I'll just do random checks on the other paper mica paper waxies, and yeah, and then maybe check the tubes, and yeah, see where we go from there. I'm kind of hoping that there isn't a huge amount that's going to need to get done here, because I have a feeling that the record changer is going to be a lot of work. Okay, so far so good. So I took out the heavily rusted fuse and figured it would just be a straightforward case of cleaning it up, but I noticed it's actually blown. So we cleaned up so I cleaned up here the 2 contacts where the fuse sits, but on closer inspection I noticed that, I don't know if you can see this, but up top there's a white wire, which is not connected anywhere, and I think pretty sure it should be onto this top lug here, which goes onto the other side of the line input. So yeah, that's not nice, because this little white wire is really flimsy, and so I got to somehow strip off some of the end of it and get it soldered onto that top lug, or the second lug there. Yep. Maybe I will take more precautions with the power supply than I was originally intending. Okay, so here's the rewiring. So the problem we had is this thin red wire here originally went to the very top lug, and connected to it, this other lug right here, was this white wire coming out of the transformer. But all these wires were quite stretched, and obviously this one had just snapped off, and so it wasn't connected anymore. So I didn't want to put particularly this wire coming out of the transformer under tension, so I just added a little bit of wire and ran it up to the top, and then I put the other thin red wire onto the lower one, which just reduced the tension on it a little bit, and so hopefully it's a little bit more robust now all around. Just need to find a replacement fuse and then do some ohming out and see how we're doing. So I took the main electrolytic out to see how it held up before I decided whether or not I needed to replace. So both, it's supposed to be 50 microfarads each section. According to this, they measure about 30. And they both failed a leakage test. So it's set to, let me see here, this is about 250 volts. And you see we're good. If I take it to the next, which is 330. Okay, now we're leaking all the time. And these caps are rated at 385 volts. So, and it's the same on the other side for the other section. So, I'm gonna have to go and put two 50 microfarad caps in instead of this guy here. So yeah, I'll probably, I don't think I'll stuff this right away, but I will maybe stuff it later. We'll see. For the time being, I'll just stick 250s in underneath and leave this in place cosmetically. Okay, it might take a little bit longer than I was originally planning to get this guy back in action. So since this guy leaks at the rated voltage or even below the rated voltage, I've ordered up a new one. But depending on how long it takes to get here, I can always just tack a couple of 50 microfarad 450 volt electrolytics in here. Checking all the resistors, quite a lot of them seem to be out of tolerance. And in particular, there are ones like this guy, this 47K here, which is in the grid 2 circuit of the EF89, this guy right here. And there's another one over here, which is, can't really see very well, but it's on that 47K. That's in the grid circuit of the ECH81. And so they would seem like really gone there way off. They're like 58, 59K values. Incidentally, this is the circuit diagram I'm running with. It's a W634 minus a 635. I really don't know what the difference is between the two. The only actual difference I've seen is the magic eye in this one is an EM80, and on my one it's an EM85. If that's the only difference, then I'd say we're good. Just having a look around the circuit diagram, it's interesting that when it's in speech mode, it's just a single main speaker that's connected. When you go to music mode, it connects to two side speakers. And I'm not quite sure what the significance here is, but this one has an inductor symbol in it, and this one has a capacitor symbol in it. And they're different part numbers, so they're not the same speaker, obviously, or the same setup. And also over here around the IF stage, when you go from music to speech, it takes a coil out. It changes the inductance on one side of this transformer. Interesting. The problem I mentioned about the silicon rectifier is there he is right in here underneath all these caps. So I might physically leave it in there and then just stick a silicon bridge rectifier somewhere around here, and it seems to be plenty of room. I could just bolt one onto the side here and it'd work. But yeah, I gotta check all the caps. I haven't checked the caps yet, but the fact that there's a bunch of resistors that are off Um, makes me think I gotta take it easy and just go through this piece by piece if I want it to work to the level of quality that I had when it was new. I can't help contrasting the different approaches to the design of how these German sets were done. So for instance, in the Tonfunk here, which I think is a masterful illustration of how you can simplify the whole process. So here you have basically essentially two concentric shafts, FM driven on one, AM on the other. There are no clutch mechanisms for engaging and disengaging, and yet you preserve all of the benefits of you know, when you go from one waveband to the other, you don't have to change the stations, etc. If you remember the Grundig I did, this whole area here was just chock-a-block with mechanical levers, which again had to be driven off the switch bank. So this had the dual role of doing all the electronic switching as well as a whole lot of mechanical stuff, and then there's a huge flywheel in here, etc., etc. And yet this achieves the same thing with a seriously reduced component count. And so the switch bank, all the switch bank does is literally activate the switches, so there's much less pressure on these, and so none of these plastic switch buttons are cracked at all, whereas many of them are cracked on the Grundig. Just an interesting contrast as you get to work on more of these sets. You get to see the different philosophies that people applied to the design, and I gotta say this one looks pretty cool. Okay, so out of tolerance resistors are replaced at this point. So this 47K here, this 47K guy right here, both of those were extremely high. There's a 1 meg resistor here that was up to like 1.3 meg, and a 100 ohm resistor over here that was again at about 130 ohms. So all those have been replaced. The rest are either okay or they're right on the line, and so I'll just wait and see how the performance is before I decide whether or not to go any further. So next I guess would be the paper caps. These tag strips are great provided you only have one layer, but what you tend to find is, for instance, it's easy when you're manufacturing. You can just put a layer of components on one side and then a layer on the other. So it's a bitch then to get at the ones around the back. We need to replace them. And for instance, as I said before, the bridge rectifier is hidden away right down there. So physically it's definitely not going to come out, but hopefully electrically it'll come out at some point. And we'll put either a silicon bridge rectifier, a couple of diodes or whatever in there. So having done the resistors, I decided to have a look at the paper caps, and so I just took this one out as a sample to see how it goes. So it's a 0.05 rated at 500 volts. Put it on the leakage test. You can get it up to about 300 volts before it starts to leak. However, the problem really is when you come to measure the capacitance. So it's supposed to be 50 nanofarads, and you can see it's like 3 times what it's supposed to be. So looks like I better go and change all these guys out, if nothing else. Here's something curious that I haven't seen before. Where the wiring goes into the filament of each valve, there are these small ferrite little guys on each wire, right? So as you can see here, you have these little ferrules. There you have one on each wire, one coming in and one going out. Then you follow the wire along. It goes up to this tube right here. And there again you see the little ferrite color on the wire. So For any of you guys who've seen this before, or the theory buffs who know what that's all about, I'd be really interested to know what the theory is and what those things are for. Haven't seen that before. Always interested to learn. So, yeah, leave me a comment, let me know what this is for. And yeah, on the circuit diagram it shows those, I assume that's what these little diagrams are here. These little blocks here represent these little ferrite rings that are around the cables going to going along the heater chain. Curious. So I'm looking at trying to establish the value of these two electrolytics. So there's one guy right here. There's another one right here in the back. So I found this one. This is a 50 microfarad 65 volt. And it looks like I found this one as well. This is 100 microfarad. Doesn't say what volts on the drawing. So here it is right here. 100 microfarads of the L84, and it's in parallel with a 180 ohm resistor. And so, yep, no problem. So this guy right here is my 180 ohm resistor. The curious learning here is I thought, okay, one end of each of these, so this electrolytic around the back and this 180 ohms are in parallel, and one end goes to ground, one end goes to chassis. And so I thought, okay, if I follow down to this lug right here, then it's got this bare wire running off to the center of this valve socket. And my experience so far has been that's all that generally goes to chassis. If I look at all these other ones here, they all have wires going directly to chassis. But not this one, not the EL84. This does not go to ground. And when I follow it up to the other end of this electrolytic, it's actually the top end here that goes to ground by another unscreened wire. So that kind of threw me because I was assuming this was the ground. It's not. Curious, curious, curious. Learning as you go. So I think really this wire should have a should be covered. It shouldn't be bare. Kind of throws you right off there. Learning as we go. I'm also finding component differences between what's in this set and this circuit diagram I'm using. So this cap here, for instance, is a 1 nanofarad, and in the drawing it's 2.5. But obviously I'll go with what's in the set now, since this drawing is for a slightly different model. But it just goes to show you got to be careful. You can't rely on this circuit diagram for everything. Encountered a slight challenge here. These two capacitors across the secondary here of the mains transformer, or it says 10 nanofarad each at 700 volts or 750 volts. And if I look on the actual chassis, it looks like a special component. It's this purple guy right here. So he has one lead coming out the top going to ground, and then it has two leads coming out the other end, which are going to each side of the secondary. Not quite sure what to do with this guy. But I guess the least I would need would be a couple of 10 nanofarads at whatever, 750 or higher, to replace it. Yeah, so I guess I'll ponder that one for a while and see what I do there. I took this electrolytic out to see what value it was, and it was 100 microfarads, but at 15 volts, and so it all checked out okay, so I put it back in. This one over here I thought was going to be like a 60 microfarad cap, but when I measured it, it said 4. So I lifted one end and took it out, and it is a 4 microfarad cap, and it seems to be okay, so I'll put it back in. So yeah, there's significant component differences between this chassis and the circuit diagram I'm using, so caution, caution, caution.